Good morning, everybody. So I need to disappoint you a bit. I don't have any equation in my slides. I don't have anything of radio in there because I want to lift a bit the perspective and to look into the network architecture aspects which needs to be there in order to enable all those cool radio technologies wherever they will be at the frequency range. As we also heard yesterday, the network is an impairment generator which possibly creates disappointment. So I would like to generate a bit of excitement that it's important also not to forget what we need to do on the architecture side. And as you see in the subtitle, we also need to find a very fine balance, how much revolution we put in and how much evolution we need to keep going on. Before we start with some kind of technical details, I think it's good to see what the service providers or the operators think about the architecture. And Franz already gave a nice introduction yesterday about the NGMN vision on the architecture, which I will not explain in detail. I will come back at the end of my presentation. But I have put there also the NGMN vision, what they think 5G should be. And I would like to point out it's not only a radio system we should design, it's an end-to-end system. It should have this full mobile and connected society. It should enable a consistent experience. And in order to do that, we have talked about path loss and ranges just 5 minutes ago. Also, the architecture plays an important role to ensure consistency of the end-user experience. And then for sure, we all hope that we can tap into new business opportunities. So also the architecture needs to be able to serve those domains pretty well in a very cost-efficient manner. Then I guess most of you know this slide, where it has a lot of numbers which are there, for example, to derive the requirements for designing a new radio access technology. But what is important, you see the three edges of the triangle, which are the use case domains we all hope to address with 5G. We all know pretty well the top domain, the massive or the extreme mobile broadband, where we know how to do the business and how to develop the systems. And we have two other domains on the bottom left and bottom right hand side, where we hope to address by means of this 5G open platform to look into markets where massive machine type communication plays a role, and as Gerhard has nicely illustrated by means of the platooning of those Lego gadgets going around, where the latency and the reliability plays a role. And what I would like to do in the following is to explain a bit what type of requirements needs to be derived for the architecture, so not for the radio, but what the architecture needs to support in order to enable such kind of use cases in the three domains. As you can see already from the subheadline, we require a very scalable and flexible architecture, which needs to be programmable. Now let's see what is needed in order to make this scalable and flexible. And in the following, I would like to guide you through 7 principles, so that we also have very diverse requirements which are coming towards the network architecture. And they all have some kind of purposes, so to bring benefits for the service providers. And you see here that we talk about better network efficiency, that we lower the total cost of operations, that we have efficient resources of all the network assets we have in that system. And then what we have already talked yesterday quite a lot, that we want to look and unlock and tap into those new business opportunities, where we all believe that the 5G platform can do a miracle. Like, for example, Industry 4.0, we have seen a nice example from Gerhard on the automotive style. And later on, I will also try to round it up again. So what are more the evolutionary things we can already do now or we need to do, and what are more the revolutionary things where we need to have a good discussion when is the right point in time to bring it in, and also how we ensure the forwards compatibility if we start the system. So let's start with the overall principle that we need to have a new connectivity model in 5G. And if you look on the left hand side, you see what we have currently as a design principle in the existing LTE SAE system. So we have more or less a transparent point-to-point IP access line. So this was driven by the case we had with the smartphones and with the mobile broadband. And I have illustrated on the right-hand side 2 use cases to show you that we need to think a bit broader and where the architecture needs to be very flexible to support that. You see with the orange lines that we have some use cases here illustrated when we have communication between the cars or between the cars and the industry, in the infrastructure, that we need to have local switching, and we also need to have simultaneous connectivity to some kind of gateways, which could be a vehicular gateway or could be a gateway towards the internet. And this is currently not possible, so we need to see what the architecture needs to have inbuilt in order to support those kind of applications. In the second one, labeled with the 2 in the dark blue, is that we need to have simultaneous connections for multiple gateways. For example, that we have a terminal who wants to access the internet, while on the other side, for example, for video optimization, we also want to have direct connectivity to the video gateway. So those type of things where we need to broaden our horizon in order to define this very well, that we need to have a different type of connectivity in the 5G system. And that's also some kind of learning for us, being so long in the mobile network industry, to see what is needed here to make this right and forward compatible. Remember the light blue box there, you see the icon so that you know where we are in. It's the reliability. And reliability we can generate by means of simultaneous and native multi-connectivity. As we have learned, there will be at least one new radio access technology which might have a confined coverage, so we need to rely on the anchor layers where LTE will play an important role. So we have different type of multi-connectivities on a lower level, and we could also have it on the higher level. So what is important then, that we build on what we have in the systems, which means that we make use of the LTE and that we provide a dual connectivity between LTE and 5G. The multi-connectivity then brings robustness and also increases the data throughput, so bringing this reliability in. When and where we select that type of connectivity depends for sure on the type of service in the terminal and for sure on the coverage where we are in. And as you see here, the benefits is that we have a better consistency of the end user experience, we have a better reliability of the connections, and we also allow and need to have this as a component to provide service level agreements for those business models we have been discussing yesterday, and where we all hope that those will be used and applied for 5G. Then Gerhard has nicely illustrated it. I have also taken this, so I think this fits nicely to the presentation before. So if we have a platoon of cars, which is in the same geographical area, there might be the need that the cars are communicating to each other, but this is not sufficient, as we have seen in the nice demonstration. We also need to have the network involved, the infrastructure. And for that, you need to have very low latency in order to ensure that the communication is quick enough. And what I want to highlight, what is the interesting combination is that you have the low latency and the high reliability requirements in combination with mobility. And that poses requirements towards the architecture. Yesterday we discussed the factory automation, where we could say we put a local network, so you don't need to have any mobility there because you have the coverage in that factory plant. But when we discuss such kind of use cases, then we have the unique combination where mobility comes in paired with low latency. And that means that we need to have then the relevant mechanisms in the architecture foreseen to enable, for example, virtual networks within the platoon, or that we have then also the low latency packet forwarding. As I highlighted the mobility beforehand in combination with the low latency, we also need to have mobility on demand. And you know that your smart meter possibly sitting in the cellar is not moving at all, so it has a velocity of 0 kilometers an hour. So therefore we possibly don't need to have all the control plane resources being operational in the network. Then we also have different type of levels of the service continuity, like we have seamless mobility, or we have any type of sporadic behavior. And interestingly, I've taken this or read this recently, that mobile network operators have observed that only 30% of their subscribers are actually mobile. That means 70% are not really mobile, they're more fixed. So what could we do with those resources hanging idle or being a provision for that 70% of the subscribers? And as you see here, We also need to deal with different type of mobility anchors. That means for those things which require the mobility, like the cast scenario I have introduced beforehand, we need to have a mobility anchor higher up in the network in order to avoid frequent handovers. While for those more local systems, we can push down the mobility anchor closer to the edge so that we bring it closer to the air interface. And for sure, that will also allow, coming back for the benefits for the service provider, that we have optimization of the traffic flows in the network and the associated resources. And then what is most important, that we somehow minimize the costs for the provisioning of the service so that we do a TCO optimization. We had been talking a lot about QoS. I think in the 5G era, we need to lift it to a next level, which we call the quality of experience. And for example, also to make clear what is currently not possible, in LTE we have currently the same QoS principles which is applied for all the traffic in the same bearer. So if we want to change this, we also need to walk away from this principle we have in LTE. And that requires then also some kind of revolutionary thinking. Then also what we need to do is a more dynamic application-based QoS. And for that we had been doing with the Nokia what we call DEM, Dynamic Experience Management. Early studies how to do that, and the results were pretty promising, that we could ensure a superior end-user experience while doing that on an application level. So really, if we want to bring this to the next step, we also need to think a bit more revolutionary in our architectural approach, and should not just take what we have inbuilt in the SAE system. And this is especially important, as we stressed yesterday, and Misha had this, service providers in 15 years will be more business to business. So if we want to guarantee service level agreements, for example, to ABB or to Volkswagen of this world, or whomever is operating it, we need to be able to monetize it. Otherwise, it possibly doesn't make any fun and any sense to do that. If we then go on the session on demand, possibly some of you know what we had been doing in 2G, in 3G, and what we had been built in 4G. So we need to improve also the resource efficiency in terms of the signaling, because for some parts of the devices, it might be an overkill to have a complete user plane working. We could do it with a control plane only, like we, for example, did in GSM. So we need to have a signaling only session. That means that we don't have all the overhead for the user plane scenarios. And that for sure goes back to those 3-4 benefits I outlined before, that we have the most efficient use of the network resources. And in the sense of if we talk about this left bottom corner of the triangle with this massive machine type communication, where we have a huge amount of devices sitting in the network, and they possibly run on a battery that we extend the battery life, if they only need to establish a signaling connection to get rid of their data. Then we will touch it also later on in the panel session, that we need to have the network as a service. I called it here, I think in the NGMN white paper it's called to put the slices, so that you can have a common infrastructure layer and then you generate a slice for this massive broadband, you generate another slice for this massive machine type communication. And depending on those arrangements, you will have a different kind of setup of the control and user plane resources. And I think then Franz will be in the panel the best person to talk about this. So I would defer any question then to the panel for that. What we need to keep in mind, this is highlighted in the subheading, that the radio access network needs to, or the terminal needs to select then the right network slice. And this might be determined by the type of the UE or the service, but we should not forget that also the radio parts will play an important role. So if the terminal is not in the coverage range of that specific slice, we might have other decision criteria to bring it into the network. So coming back, you remember this slide, and I have walked you through the different examples, and also remembering the subtitle I had, so what is the right balance between evolution and revolution? And as you hopefully recognized, in order to bring down the latency for the tactile communication, we need to do quite some things in the architecture to do this. We need to have lifting up from quality of service to the quality of experience, and also to have this mobility on demand. So those are the things which are more in the domain of the revolution. And therefore we need to have a very objective discussion and also decision then when and how we do this timing and phasing of those things. Those things here more on the right-hand side I would call more in this evolutionary space, because some things are on the way or we could put into the existing architecture if you want to do so. So that is a discussion we will have over the next months and a year in order to do the right pipelining when we start to go for standardization in order to have also a workable system for commercial deployments 2020. Coming back on a simplified network architecture, I think this is, if you know the NGMN slide, this is rather similar. So we have a bunch of what I called here access front ends, because some part of the radio functionality could be put into this distributed cloud, more this edge cloud, so depending on the interfaces and the needs. And then you have different depending on the domain you're in, so those are the different slices where you have distributed network functions, different arrangements of the user plane gateways or the C-plane things. So we expect that we have a centralized cloud and a distributed cloud, all running for sure on virtualized resources for the common infrastructure or the transport layer, which I have not put in here. Essential is here what is a bit possibly limited on the right-hand side in terms of the box, is that we have proper management and orchestration of those slices. So that is something possibly we should not ignore and would deserve possibly a completely different session in order to have this management right, because also on the service provider side, I expect that this requires also some changes in the workflow, in the setup how service providers operate. And I think that's also something we can debate with Franz, how Deutsche Telekom is preparing for that, or David from Vodafone can also jump in then for this. As I like to be very precise and also to bring some take-home statements, I also want to make you aware what we should do. And this is what I think is the key to success or the call for action. And I think NGMN plays a key role here. So we have now a nice white paper. I read it again while flying here to Sweden. We have, I think, 8 use case domains. We need to have a clear and strict prioritization of those use cases. So what to specify first or what to digest in the first menu in order to progress. And I've understood, and maybe the Franz and David can also comment, that NGMN is in the process to do that, because if we don't have this clear prioritization, then also we will have problems in the standardization to go forward. So this is really important that we get this input from the service providers. Then for sure we should not stop innovating. So therefore it's important that those things which are ongoing on various research platforms are continuing to provide and feed and challenge ourselves, bringing new networking concepts and architecture ideas, which will then also feed the later on standardization. So what is now key, or 3GPP will start their machinery in September this year, and I expect they will start again with the radio focus, which is okay because it's very concrete. You have numbers, you can do link budgets, you talk about frequency. But if we do this in the wrong way, then we limit ourselves again. So we need to have, or what 3GPP needs to do, to time this very well and to phase this very well. So what to do in the radio, how much we take from the existing architecture, and how much revolution we want to bring in. So that needs to be done very properly, where I would like to ask all of us here in the room that we try to ensure that we are making the right and bold move. And important is here, if we start with the radio and start small and do dual connectivity with LTE, we need to have to ensure that we have the forward compatibility. Otherwise, we sit here again in 5 years and start again a new generation, which is possibly not really healthy. And I think what is important also, I put here by intention the euro sign. It's about the money. At the end, we design something to make some money out of it. So that we need to have a very fine granular balance between an evolutionary approach and a revolutionary approach, in also order to ensure investment protection, because the networks are out there. there's a good reason why there's a core network for GSM, UMTS, LTE. Operators are making money for it, and I would expect if we argue, no one will throw it away. So that's to bring a bit of reality into the discussion. And also then we need to ensure that we have this future-proofness we all would like to have from this 5G platform. With that, I come to the end of my short presentation, and I'm open for questions.
Very good. Thank you, Peter. Questions?
Thank you for the presentation. I think the use case based approach is kind of two-edged sword because I mean when you come back to 3G, at the time of making 3G standard, no one even dreamed of Facebooking as a top application that made 3G survived. So if we try to think of use case at the moment and how I mean, we don't know what kind of real use case would come up in the future, and we don't know what kind of impact that we make of our making system tailored to use case of what we dream of today could impact tomorrow. So how do you think?
Yeah, I think that is the chicken egg problem. So we need to prepare for the unknown. Because we might think about use cases today which might not have any commercial relevance. So that's that we have this inbuilt flexibility for sure. We should not put the maximum flexibility in by all means of all the costs. So that's something where I expect we are wise enough. We have done this already over several generations so that we make this as a concerted action and then decide on the right setup for the different phases.
Yeah, I think the easiest way to address the topic you're addressing in terms of the engineering part of it is to actually take some application and run it through, you know? Because if we're looking at the 5G system, the number of applications we see are so many that it's very difficult to say, look, this is a generic spec, and this is how we sort of have to build the whole system architecture to match the requirements. So my way would be just to take one or two cornerstone application areas like factory automation, like mobility that you showed, and say, let's grab these and try to make a solution together with those industries from a system architecture all the way to the air interface. Because it has been done before once, right? It was Flarion's Flash OFDM, where they used Microsoft Office and optimize the air interface to interact with Microsoft Office. And so the look and feel was better than any other system. And so it can be done. We know that as an industry. But we should actually look at these kind of applications. That's the way I feel. How do you feel?
No, I fully agree. So I think we have been talking now about requirements for the last year. Now we need to get more concrete, and we need to nail down it, like concrete use cases, or like you had this example with how the platoon behaves, to really understand, do we really need this 1 millisecond? Do we really need to have whatever this mobility? And then really to see, okay, what are the cornerstones? And I fully agree that taking possibly some extreme use cases, 2 to 3, but then we need also to understand those industry and have those players around the table. And I think this is still work in progress. I think we had been debating it 2 years ago. We had been debating it last year. So this is still work in progress.
Yeah, good.
Okay, we anyhow have a panel later on.
Yes.
So keep your questions and shoot later on.
Yes. Thank you very much.
Thank you,
Peter, and thank you, Aaron.